In 8.47 we have ozone reacting with nitric oxide, and that's O3 plus NO. That's going to produce NO2 and O2. And then the question says, if 0.740 grams of ozone reacts with 0.670 grams of NO, how many grams of NO2 will be produced? So this is exactly the type of question that you need a balanced reaction to answer. So just write that info down. We want to know how many grams of NO2 will be produced. That's what we're interested in. Okay, so to answer this, we need to first balance the reaction. And the reason for that is because if I don't balance it, I don't know the mole ratio that these things are reacting in. And if I have a certain number of grams, that represents a certain number of molecules. But if I find that, in order for ozone to react, it requires a specific number of NO molecules to react with it, and I don't know what that number is, I'm not going to be able to determine what quantities of my reactants are actually going to be consumed. So I've got to start by getting that relationship in terms of the numbers of things reacting in the balanced reaction. So to balance this, I've got 4 oxygen already on both sides, and 1 nitrogen already on both sides, so it's already balanced. So that's nice. If it was not balanced, I would have to balance it first, because these coefficients are necessary in this calculation I'm about to do. And I don't want to ignore them. When we've been doing conversions, we've been finding relationships. Right? So if you want to convert from grams to kilograms, you need to know how many kilograms equals 1 gram, or how many grams equals 1 kilogram. You need that relationship. And so what this question is asking ultimately is, if I have this certain number of grams of O3 and NO, how many grams of NO2 will be produced? It's a conversion. They want me to express these quantities of reactants in terms of the quantity of product that I can get from that. So anytime you have information about one substance, in this case O3 or NO, and you want to convert that into information about a different substance, in this case they're interested in figuring out how much NO2 we can make, you've got to convert to moles. And you have to use the mole relationship here in the balanced reaction. In this case everything happens to be 1-to-1, but most reactions are not 1-to-1. And that mole ratio is the relationship between the quantity of one substance in a reaction and the quantity of a different substance in a balanced reaction. So if I'm working out my relationships, I can say 1 mole, in this case, of O3 will produce 1 mole of NO2. Because the ratio happens to be 1-to-1. If in the balanced reaction I have different coefficients there, those coefficients would come into play in that relationship. And I can also say, because it's a 1-to-1 ratio in the balanced reaction, 1 mole of NO equals 1 mole of NO2. So it's important that we balance that to make sure we understand what that relationship is. That's the only relationship you can ever use to convert between information about one substance and information about a different substance. It's the mole relationship. And you can only cancel units in these conversions when they are units that belong to the same substance. I can't cancel grams of NO with grams of NO2. They're not the same thing. So when we set up these conversions, we're going to be using the same method. We're going to be multiplying these starting amounts by factors that are equal to 1, so we're not changing the quantity, we're just changing the units. We're going to set it up so that undesired units will cancel and we'll get the units we want. What we want is grams of NO2. What we have is grams of a different substance. To convert from one substance to another, I've got to get to moles first. So what other relationships do I need? I need the molar masses for these substances. So I need the molar mass for O3. Just calculate that. So oxygen, 15.999, 4 times 3. So for oxygen, that's 47.9982 grams of ozone equals 1 mole of ozone. So that's for the O3. Another relationship would be for NO. So 1 nitrogen and 1 oxygen gives me 30.006 grams of NO in 1 mole of NO. And then I'll probably also need that relationship for NO2. So 1 nitrogen plus 2 oxygens equals 46 grams of that substance in 1 mole of that substance. Notice all these relationships, these gram to mole relationships, they're all grams of a substance per mole of the same substance. The molar masses only allow me to convert from grams to moles for the same substance, not from one substance to another substance. It's the mole ratio I need from the balanced reaction. That's the only relationship that will allow me to convert from one substance to another substance. So I highly recommend to you that you include the substance with your unit in these conversions, not just writing the unit. So if you just write grams, if you just write 0.670 grams, you don't know, and you're trying to cancel that, you can only cancel grams of NO with grams of NO. You can't cancel grams of NO with grams of NO2. They're not the same thing. So keep track of your substance and keep that with your unit. So what I want to do is convert these 0.740 grams of O3 into grams of NO2. So I'll use the relationships I have. So this relationship here tells me that I have 47.9982 grams of O3 equal to 1 mole of O3. If you don't know what to do in these conversions, you're not sure what to do in your first step, just convert whatever you have into moles. Almost every conversion has to go through moles first, because there's so many relationships we have that involve moles. It's very likely that at some point you'll have to convert to moles in order to use one of those relationships. So we just convert the amount we have in grams into moles first. Now I want to convert that quantity into an amount of a different substance. I use the mole to mole relationship, and this is important. And here it's not going to change the math, but if we left it out and the ratios weren't all 1-to-1 in the balanced reaction, the coefficients weren't all 1, if we didn't do this step we wouldn't get the right answer. So we need the relationship between moles of O3 and moles of NO2. And that comes from the coefficients in the balanced reaction. In this case, they happen to both be 1, which we already wrote that relationship down. So notice, I converted out into a different substance, into the substance I was interested in. If I want grams of that substance instead of moles, I would use that substance's molar mass, which was 46.00554 grams of NO2 per mole of NO2. So notice I can only cancel grams of O3 with grams of O3. I can't cancel that with grams of something else. And I can only cancel moles of O3 with moles of O3. And moles of NO2 with moles of NO2. But I'm able to do that and get the substance I want. So if I carry that calculation through, I get 0.709 grams. Is that my answer? Right. So, right. So what I've just calculated right now tells me if I assume this entire amount of ozone reacted, then I could get this amount of NO2 produced from it. But it might not be possible to react all of the ozone I have. If I don't put any NO with the ozone, then none of it's going to react. So depending on how much NO I have, I may be able to react all the ozone, I may not. So I have to figure out how much product I could get from the other reactant as well. I have to do this calculation twice. I have to do this calculation as many times as it takes. One for every reactant I have. If my reaction had 10 different reactants, I would have to do this 10 times to figure out which reactant I actually run out of first. That's the limiting reactant. The one that can actually produce less product is the one I run out of first. That's actually the most product I could make from that one, because when I run out of it, I can't continue to make more. So I've got to do the same type of calculation here. So if I'm starting with NO, I'll use the molar mass of NO. Convert to moles first. That way I can use the mole relationship that comes from the balanced reaction, the coefficients. And so if I plug that one into my calculator, I get 1.01 grams of NO2. So this also demonstrates how you can't just look at the starting amounts in grams and say which one is limiting. It's not correct to say that whichever reactant I have less of in grams to begin with is the one that I will run out of first. It's not necessarily true. So if you want to know which is the limiting reactant, don't just look to see which you have less of. You need to do these conversions, figure out which reactant actually limits the amount of product I can make. With the amount of ozone I have, I can only make 0.709 grams of product. With the amount of NO I have, I can make 1.01 grams of product. So that means I have excess NO and the ozone is limiting, and the maximum amount of product I can make is this one. I can't make 1 gram because I've run out of ozone. I only have enough ozone to make 0.709 grams. So the rest of the question says, which compound is the limiting reactant? It's the ozone. Calculate the number of moles of excess reactant remaining at the end of the reaction. To do that, I would need one more conversion. So I'm just going to, we've already balanced the reaction. We know the relationships. I'm just going to create a little space to do that conversion. So this last part of the question, the number of moles of excess reactant remaining at the end. So we determined that the NO was the excess. So to get the moles of NO remaining left over after the reaction, that's going to be equal to the initial moles minus the amount of moles reacting. So I need those two amounts to figure out how much is left over. I've already got the starting moles right here. I've determined that my NO is in excess, and I know how many moles of it I'm starting with because I know the grams I'm starting with, and I can convert that to moles. So I can just do that real quick. That gives me 0.0223 moles of NO to begin with. How do I figure out how much NO is actually going to react? It's not going to be the whole thing. It's going to be limited by how much NO the ozone can actually take with it when the ozone reacts, right? So I figured out the ozone was my limiting reactant. So what I'm asking here is, when this ozone completely reacts, how much of the other excess reactant is it actually going to take with it? So the conversion I want to do here is to say how many moles of the NO will react in this point if the 0.740 all the grams of ozone were to be converted into product. Right? So I take the limiting reactant and figure out how much of the excess reactant is actually equal to that, or will react with it. That will tell me how much of the excess reactant is actually going to react. So I can subtract that from the initial amount to get the amount left over. So I would use this, I want to convert from one substance, the ozone, into a different substance. So I've got to convert to moles first. So I would start this the same way I did the first one, going from grams of ozone to moles of ozone. Then I would go back to the balanced reaction, and the ratios happen to be 1 to 1. So this relationship between moles of ozone is a 1 to 1 mole relationship between moles of ozone and moles of the other substance. You can find the relationship between any two substances in a balanced reaction by looking at their coefficients in the balanced reaction. So these happen to be 1 to 1, so 1 mole of ozone needs 1 mole of NO to react with it. So now I've got these canceled. I've got the units I want. So it's going to be just 0.740 divided by 47.9982. That gives me 0.0154 moles. So if I start with 0.0223 and 0.0154 reacts, when I subtract that, the difference is 0.0069 moles of NO. So that's the amount remaining unreacted, because the limiting amount of the ozone can only react so much of the NO before it's gone, and I don't have anything left. I'll still have NO left, but I run out of ozone because it's the limiting reactant.